One of the things you're going to want to do a lot when you're building your programs is you're going to want to manipulate data values. Sometimes we'll use mathematical operators. And in this tutorial, that's what we're going to talk about, the syntax for operators. The way we get to the tutorials, we're going to go to the tutorials for week 2 and click on the operators. All right, now when we're talking about operators, we're talking about simple values where we are doing, let's say at the simplest, we're just doing operations like we would on a calculator. The the so-called syntactic operator for adding two values is just the plus sign, subtracting is the minus sign, multiplying is the asterisk, and dividing is the forward slash. And the way that this looks in a program is if we do an initialization statement, we could declare an int called x, and we could assign the value with the assignment operator of y plus 1. And likewise, if we wanted to multiply x by 5 and reassign the value of the x times 5 back to x, changing the value of x, it would look like this. Another operator that's maybe not so obvious is called the modulus. It looks like a percent sign. It's just the percent symbol on your keyboard. What the modulus does is it returns the remainder of a division operation. So if we look at this expression, we have a variable m, and we're assigning it to 13 divided by 4 and the remainder thereof. So 4 goes into 13 3 times, 12, and 13 minus 12 is 1. And so that would assign the remainder to the value of m. Now there's, just like we talked about in the conditional tutorial and in the lecture when we were talking about conditionals and loops, we have some shorthand ways of doing this. This is the expression we just saw, x times 5, and the new value is put back into x. The shorthand for that is asterisk equals. This is shorthand for x equals assignment x times 5. And likewise, just like we saw in the in the lecture, we have another alternative shorthand for integers, specific to integers, that increment or decrement some variable by exactly 1. So x plus 1, x plus plus rather, evaluates to x equals x plus 1, x minus minus, x equals x minus 1. These are very common, especially, for example, in loops or other sort of control structures that you might use. Booleans, we know from the lecture, are values that take exactly the value true or false. True evaluates to 1, 0 evaluates to false. If we declare a Boolean, it's a very specific thing, and we might want to use it to select data or something else in our program throughout. But all Boolean expressions evaluate to one of those two discrete values, and we can use that in a conditional. And we've seen that before in the lecture. And there's a bit of a funny point, is we actually don't have to declare formally a Boolean. Every non-zero value is equivalent to true in C, and every 0 is false. And so we can formally declare it. We don't have to. Sometimes there might be a reason to do so, and sometimes not. It's always best to do so if you're unsure. Two main types of Boolean expression are logical ones and relational ones. We've possibly encountered some of these before. Logic is called about the branch of mathematical reasoning called logic, and it uses sort of set theory. So we use the and symbol to represent and if we're using and, say we have two variables x and y, this little table says, if you've got two truths, x and y are both true, and we evaluate the expression x and y, two truths evaluate to true. But if we have one false at all in either variable, it will always, if we have at least one false, it will always evaluate the false. So true, false, false, true, and false, false evaluate the false. On the other hand, we have or. This vertical line is referred to as the pipe symbol. It's just next to the left shift on the British keyboard. Here, if there's a true anywhere in a comparison, a binary comparison, it will evaluate to true. So true and true is true. True and false has one true. False and true have one true. They're both true. But if we have no trues, false or false, it's always false. And we also have a not operator that inverts the value of a single variable. So if you have x equal to true and we evaluate not true, just the exclamation point, it evaluates to the opposite, false. And likewise, not false equals true. Now, these relational operators are ones we have encountered in the lecture. They're the less than and the less than or equal to symbols, and the greater than or equal to symbols. And likewise, we have this equality operator, equal, and an inequality operator, not equal, with a not sign. Equality just asks true or false, are these two values in x and y equivalent? And inequality asks, are they inequivalent? A common mistake here is to kind of forget to use the second equal sign if you're trying to evaluate an equality. And what that would do is it would assign the value of y to x. So it's a very common syntactic error. This is just a short demonstration of some of these operators. You're definitely going to encounter these. We're going to be using these a lot in almost every program. They're super useful. You'll become good at using them, and it'll become logically, intuitive for you to use them. That's all I have to say about that.